Hello and welcome to the Nerding and Hoarding show. I have just created this specific layout right here because, and yes, it is the 555 timer, the NE555. And in this circuit simulating program called Falstad, it has You can use this chip, but unfortunately it comes out looking like this, and I have no idea how to use this because I used it so many times when it looked like this as its footprint, and this is sort of its logic layout. But when I have created this, I will use it. So I have saved this as a specific file, and then I open it and I save as. So now we save as, and we will start from the beginning, so to speak, which is, so it's a basic astable multivibrator that we are going to build. Something that is very, very good to have, and that we can modify in many different ways and do very many cool stuff with. So please excuse the crappy layout inside here, but it doesn't matter. Just ignore everything inside and just look at what is outside. So for the simplest, most basic astable multivibrator, which is basically an oscillator or a voltage controlled oscillator also, sort of. So first thing we do is connect pin number 1 to ground. Yes, the second thing we do is connect pin number 8 to voltage. And here we can use between 5 and 15 volts, or a little bit more, or a little bit less, but we say 4. 5, between 5. So you can use a battery, you can use 12 volts, you can use 9 volts, you can use 15 volts, 5 volts, 4.5 maybe even. So please just do that. That's very fine. And just connect some voltage right there. Let's make it 12 so we get some control over what we are doing. Then we add a small resistor between here and there, between 8 and 7, small resistor, and then we attach a potentiometer right here between pin 6 and 7, and this could be maybe a 100k, like this. And we have our output on pin number 3. Let's watch it. So nothing is happening yet because we have not attached a capacitor. So we need a capacitor between pin 1 and pin 2, like that. And we can just put a 100 nanos there to start with. Then we connect pin 2 and pin 6 with just a diagonal wire like this. And we also connect pin 8 and pin 4 with another diagonal wire. And there you go. We have our output going. So with just 1, 2, 3, 4 components and an output jack, we have a 5-component oscillator. If you are really want to save components, you can also remove this and connect this as a voltage divider like this. It makes it a little bit more strange because the duty cycle will be changed when you change the frequency. So you see we get a lower frequency but we also got a shorter duty cycle, and as we shift to this direction we mostly actually change the duty cycle, but we get some noise that is changing. So let's go back to where we were before. And let me just say, you can put an output jack right here and you have built your first oscillator. Congratulations. So I will save this as, yeah, I already saved that. So yes, yes, and I will call it 01 because we will do something more and now, so I just save it again as a new file. Will it be? No, I just make it a version of this. Okay, so this is version 2. Maybe it's good if I write to that. Yes, so what we can do more is we can control the frequency, or at least we can control something with this pin. It's actually called CV, so why don't we attach a CV to it and see what happens. Let's see, what do we want? An input of a square wave. No, an AC, a sine wave, but it has to be very slow, like this. So, you see what's happening there? Let's also include this in the existing. So you see it's very slow, so just like we make it a little bit faster like this. So you could use this to control the frequency, and you can also use it to, I'm just gonna make it go from positive 5 to 0, like that. Or I mean, yes, we are using 12. I'm so sorry, like this. Yes, but we can also use it as a low, what is it called? A phase modulator. So as you see here, we are now controlling the frequency with an incoming voltage right here. So very simple. We just put the jack here and we put in something and we get something out. So maybe it's time that we actually listen to it, because it's a noise channel, so we need to hear some noise. Right. Unfortunately, I'm having a problem with my setup, so every time I'm gonna hear something, I need to disconnect the microphone, so I can't speak, and then I might forget to connect it again, but hopefully not. So here you go, some horrible. What was that? Yeah, there you go. Sounds like a toy machine gun or something. Okay, yes, so, all right. So that is what we can do as well. So let me just save and make the next one. So save and then save as. And we make number 3 because there is no end to the possibilities of this particular circuit. And I mean, I'm just scratching the surface here, of course. So if we just disconnect this for a while, in order for it not to disturb us, then what we can do is actually take a signal from here and we could listen to that one instead. So let's just see. We will just change this whole thing like this, and we will both see and listen to what is actually going on this pin right there. So let's look at it. Oh my god, you see that? That is a triangle wave now, if I ever seen one. And it sounds like very beautiful, harmonic. If we add our yes, as I said here, now we have when we used this previously, we were going from 0 to 12 to 0 to 12, and we totally changed the frequency. But what we can do if we keep offset at 9 and we just do this sort of 300 millivolts and see how that sounds. So let's reset and put this 2 there and run it until everything is ready, and then it's gonna all right, but then comes the unfortunate part to this using this output. It's because we can't take output from here and use it without affecting what's happening inside. So then we need to use a buffer. And the buffer is a thing that takes a signal and just listen to it, and then makes a copy of this signal and makes it very, very strong, or as strong as the output thing that is connected to the output needs. So we can do this in one of two ways. One way is use an operational amplifier that looks like this. We then connect the input to the thing with the plus, the non-inverting input, and we connect the inverting input to the output, and then we can take the signal and use it. That's one way to do it. But you also unfortunately have to connect this to a voltage. So if we use instead what is called here a real operational amplifier, that means you have to put voltage here, and that is also inverted or upside down. So what you need to do is give it negative voltage here. So you have your normal positive voltage right there, and you have your negative voltage that you have to have a power supply with positive and negative voltage. But then you get an output that is working like this. So let's just all right, you are then getting, yes, but what if you don't have a dual power supply, as it's called, or yeah, whatever, plus and minus? You might try to connect this to ground and see if it works. I'm not sure, but you never know. We can always try. Let's see. Well, it seemed to work. But there's another way that might be easier, but it uses more components. So if we take a resistor of a value, so sort of large value, I don't know, 100K, and then we take a Darlington pair, which is, you could buy it, but you can also make it with just two standard MPN transistors like this. And then you connect it like this in this configuration, and maybe we also we can test this, but maybe it doesn't work. No, so we also have to put another resistor to ground right here. So it's sort of pull down resistor And now it should work. Yes, you see it's working. And you see this uses 4 components, unfortunately, and this uses 1 component. But I would say this could be easier if you are, well, it depends. You know, there are 2 alternative ways right here. So I will actually maybe do a little thing like this right here. A throw switch. This is called a throw switch because it can throw things from one side to the other. So we have, and I will try to just make this clear here what this actually is right here. Oh yeah, so I write here, yes. So you can use triangle output, but you have to buffer it. All right. Now what's going on? Doodle Rena, what is this? Here. Okay, you have to buffer it. Here are 2 alternative buffers. So there you go. We have 2 alternative buffers. So choose one of the other. But you know, I don't know if we're gonna talk about the problems or the possibilities, but let's just say that we have the signal right here. So okay, we have the signal right here coming out of our buffer, but you know, if we think it's too weak, so what do? We attach an amplifier. Because we use this as a buffer and our IC has 2 of them, so we use the other one as an amplifier then, because we have learned a little bit about that you can amplify signals. So we simply build a non-inverting amplifier like this. Which is very straightforward, and we are thinking like, wow, that's so good, I built this amplifier right here. But unfortunately, I must spoil this for you. Alright, so here is your signal, I believe, I hope. Yes. But what happens when we amplify it? It goes up, it goes up, it goes up, and then it disappears. So that's most unfortunately. Why is that, we say? Why can't I amplify my signal? So then I pull down the amplification again and we look at what is the problem here. Well, the problem is something called a bias voltage. And what that means is that this wave is not centered around 0, it's centered around somewhere like here, 8 volts. So it's going from 5.5 to 10.5 volts. And there's nothing we can do about it in that circuit. But there is one thing we can do about it after we buffered it. So when we buffered it, now we can actually remove the bias. And the way we do it is very simple. We take a capacitor that we put in series with this, and then we take a resistor of a rather large value. Let's just say 100k, and then look at what's happening. So look at the wave. I said look at the wave, and then you're supposed to do your thing. Alright, if the thing will happen, but it goes very slow. So if we decrease this value to maybe 1.5, and look at what is happening, the wave is sinking, and it's keep on sinking, 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 until it centers around 0. And now see what happens when we amplify the signal. It just becomes huge until it hits the roof and becomes a square wave. So you see, with just a few simple components, we have now created a triangle wave, which we can amplify and change the waveform between yes, so we can actually change the waveform here to a square wave. That is because if you amplify something sort of with infinite amount of amplification, it becomes a square wave. And so we can get it also to be between square and triangle here, if we are interested in that kind of thing. You see, this is really great thing, you know? We can draw sort of monster mouths and houses and things right here. So there you go. Yes. And let's just say, yes, I will move this a little bit over here. So make it more clear what is going on here. Okay. And here, let's see here, we remove the bias voltage. And I will just write it in another way, so that the wave centers around 0. So I accidentally pushed the caps lock there. I'm sorry about that. So then, and then we can amplify it. Sorry about my spelling, but you know what I mean. Amplify it. All right. So file save. Save as. Now let's make number 4. What more can we do with this little thing right here? Well, there are so many alternatives that we can do. Yes. If we're... I'm not absolutely sure about this, so you have to bear with me when I experiment a bit. But sometimes... No, wait a minute. I got an idea now, don't I? No, I don't got an idea. I don't got that. No. Alright. Maybe we should finish there for today. And And yeah, thanks for watching. In case you do watch, that is. All right. So just go back, go back, go back, go back, go back. Did I change that? Okay, so edit. So okay. So we can amplify it. All right. I will just add some more texts around here. All right, so I just export this as an image. Because you know this channel, what is it all about? Well, it's about designing, simulating, yes, and layouting, yes, and finally building. So we are at 27 minutes, so we have plenty of time to make the layout here. If I just quickly do some adjustment of this previous circuit image. If I can find it, yes, it's sort of right here, but I can't see it. Please move. All right, so we got this here. Adjust, invert, image, image, adjust, desaturate, image, adjust levels. Beautiful, beautiful. And you know, the most important thing that I will do, I will clean up this inside here, the inside mess, like that. Yes. So where is we? Where is we? Where is we? Alright, sorry for saying such stupid words all the time. I can't help it. It's just a problem of mine. So let's just save this as a JPEG and let's go to designing. I mean layouting. Yes, so first thing we just write what is it with I. I is nerding and hoarding is, and then who are you? No, I'm just kidding. What is this? This is variations of the 555 oscillator. Yes, and of course this is super large. Everyone knows who I am because, you know, what's my name? Nerding and HOARDING, ding, 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 dong. All right. Come out, wherever you are. So the thing about astable, it just means that it's oscillator. So don't mind that if you don't understand what it means. It's not a very unstable oscillator, it just means oscillator. Because we can also make a multivibrator that is sort of just timer. So you just click a button and something goes up and something goes down, and you can use that as a timer. Right. Oh, fuck my leg. I'm sorry. I shouldn't have said that nasty word right there. So, I'm gonna do something backwards today just because I can, because I am wanting to do something backwards today. So let's start with the panel here because we are building Euroracks, right? We're not just building anything else. And we need 2 jacks, 1 and 2, and we need 1 let's see, what is it called? A knob, because we're having a what? Yes, by the way, these you cannot find these in your program because these are made by me. So sorry about that, but if you're very interested in them, I can probably upload them to somewhere if you write to me and say you want them. Where is... Alright, so okay, doesn't want to work really like now, so just do it like this, the manual way. And the value here will be a stunning 100k. Bam. And you know, if you want these rings to go away, you can set a very small value here, like 0.1, and you get invisible rings, because I never seen rings on my potentiometers. Alright, so now we make a very small little strip board. Well, not that small. Yes, small like this, with a power header, as it's called in Eurorack, you know, Eurorack. Eurorack has a special power connector that I use, and that you also can use. Oh, I'm sorry, I removed these lines here. You must remember that there are lines like this. Okay, what happened right there? Okay. So I said lines like this. And we have to, of course, draw that on top of here as well, because I unfortunately removed them, which was not my intention, but it was just happened, unfortunately. So, yes. So anytime that we are doing anytime when we are doing something with stripboard and with ICs, integrated circuits, we need to make such holes in our stripboard, because this one will connect to both sides, and then we need it to isolate this pin from the pin on the other side. So always a good thing to start by doing as many holes as there are lines. So in an 8-pin depth, you make 4 holes, and if you have a 14 dip, you make 7 holes. Right, if we look at our little image here, we can start with making a drawing layer here. You don't have to learn this. This is not important to do this in this way. It's just my method of making sure that I remember what I have done. So the first thing is first, attach positive voltage, and we have actually positive voltage right here because we have the Eurorack connector. So then we can say we have plus, we have ground, 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 and we have minus. And these are 12 volts, so we can write 12 there. And it's just one step down here. So the first one right here, this is positive. Excuse me. I said this is positive voltage. So we have automatically connected this correctly. So the next step is to connect our ground. And now we have ground here, here, and here, which is not so good. So what we can do then is make some more holes here, here, and here, and then we connect a wire. Just connect every part of your 3 ground wires or 3 ground strips. I don't know why we do that always, but I always do it anyway. And then we connect it to this one right here. And in order to remember that we are actually, because it's sort of invisible right there, so I add a little dot here. So I know that these are the soldering points right here. So now when we look at the ground plane, it's like this. And if you remember, the ground is here. And we want it to go in there to pin number 1, which is here. So we just add a very small green cable there, or whatever color you prefer. So let's see where we are now. Yes, you see here we have also this one. 4 is supposed to get the positive voltage that is over here. So we could add an extra line here and sort of bounce it up like this. I mean down like this and then up again like this. Or we could just do a straight line like that. But this will make a more easily understandable, or maybe not, but it's less messy this way. But you save one line of stripboard if you do it this way. So you can do it any way you want. Anyway, now this is connected right there. And so let's move on to this capacitor right there. So between pin 2 and ground, anywhere on ground, we need to add a capacitor. So just from here to here, I guess, that's good. Just makes it a little bit transparent and make it 100 nanos and 50 volts if you have the same that I have. That looks sort of like that. Alright, so that is finished. But you see we have 2 things going on from this point right here. 2 things. One output if we want a triangle output. So why don't we take one more line and do sort of the same thing as we did with this one. That we actually bounce this down to a new strip. Like this. You see how beautiful that is? And then we take that to pin number 6. So double check, and you do this by pressing Alt key and press where you want. So all of these areas are connected now. And if we look at this, pin 2 and pin 6 are connected to each other, which is very good. So then we just have this little thing to worry about. So anywhere on this green marked space, we can attach a wire that is this kind of long wire. So I will do it right here, please. Yes, and I will take the same color here. This code right here is the color. After the hashtag, you get the color code. So you can copy that and paste it if you want the exact same color on 2 different wires. And what was this now? What was this? Well, this was the triangle. No, wait a minute. This was not just. So this now needs to go to, we will actually not use this throw switch, that was only for show. But it will go to a buffer here. So we could do like this for simplicity. We just write here out unbuffered triangle. Unbuffered triangle wave. And just keep it like that. And we don't use that right now. So then we don't mind everything that is on this side of the circuit. Instead, we move to pin number 3, and that is right here. Right here. If we want to, here's where the output will come. If we want to, we could attach a decoupling capacitor here, but strictly speaking, it's not necessary. What it will do is something, maybe it will remove, make the wave center around 0, I'm not sure, so I will not add it. I will just do like this, and I will take away pink. So like that, and then we write here square out, so we know what it is. Square out, sort of, and we write, we can write what is the voltage, plus voltage to ground, just to remember. I mean, that's something you can easily forget when you have built a module and you don't, what is it actually putting out, you know? That's not so easy to remember. And then we connect a ground to the jack right here. And we have ground on the circuit everywhere here. So just choose one position where you think it will not be in the way, and that your cables will not be entangled very much here or crossing each other. Unfortunately, well, we could actually, if we make like this with the wire, it's not crossing with the other wire. But this is just for making things look a little better, and you get less confused when you try to build it. If you have a lot of wires crossing each other, it's even if you color code them, it's still extra problems to get it to work. So then we have our out. I just write like this. Wow, this is a nice font I created. If you write really fast like this, it sort of can't keep up. Yeah, you saw that I did like this, but it can't keep up. Anyway, that's a sidetrack that we will leave for now. So now, focus on this one right here. Between 8 and 7, we have a 1K little cute little thing called a resistor. 1K 250 millivolts. I mean, when you choose it here, it says quarter of a watt. Yes, quarter of a watt. Yes, but you still have to set it here. And this is a quarter of a watt, not volt. I'm sorry about that. I said the wrong thing. So now we are actually, yes, now we are at this one, which is this one right here. So it's a potentiometer. We can turn it just to get it in the same orientation of the legs as the image right there. So you see the center leg points to the left. Center leg points to the left. Center leg is connected to the down leg. So down leg connect to center leg right there. Then we just take a wire and do that. And unfortunately, we have to send the panel backwards in order to see it. And we can also transform this and bring it forward. No, I did something wrong there. Okay, so that is done, this particular wire right here. But we still have to connect, here. This is not connected yet, even if I am, well, that was connected. But, from here to here and here to here. And that is, so the bottom leg right here should go to pin number 6. And pin number 6 is right here. So it's a bit crowded here. Actually, we could have picked one step larger strip board, but since we didn't do that, we will just put the wire right in this hole here. And things look a little messy now, but we will have to survive that. And what did I say? Connect it to the bottom leg right there. And then we take another one. So we could just copy this and take, but now we need another color because we're gonna see which one is which. And that one goes to pin 7. See here, goes to pin 7 right there. And pin 7 is right here. So also a bit crowded, but it is possible to put two things in the same hole. So that's what we do right there. We could also choose to make these two wires a little bit transparent just to make things easier for our brains to see. And yes, we are almost done with this little thing. We only have one thing more to do, and that is the frequency modulation. I just love to say freak mod, so that's what I was right there. So the freak mod, what is a freak mod, you might wonder? Well, it's something that controls the frequency by voltage. We can't really use this as a voltage control oscillator. Well, we can, but it can't play in tune or anything, but we can make it sort of into a siren, like wow, wow. And if you add a very small fluctuation here, you get sort of just like sort of like a violin or something. So you insert a low frequency oscillator into there. And let's just connect the ground here, here, and then we just attach this to pin number 5. You see here? Here we can input frequency modulation right there. You see? How great is that? Right there. So we just take a wire of any color we want. Unfortunately, now we get a little bit of problem because do you see how this looks now? If we zoom in here, please zoom, I said zoom in, yes, it looks like it's soldered right there with this also, right? So we maybe have to do like this, even though it's better to always keep the lines straight from up to down, but we do it like this now, and we invent a color that we haven't used before, such as orange, and then we connect that also to here, and we are ready. Yes. So we're ready with the design. Now it's just some extra work that I do always because, not always, but I try to do it always because it's helpful. So make a copy of everything and then select, transform, and mirror horizontally. Yes, and then take every... No, wait a minute, don't do that quite yet. So let's see, what do we do? Yes, take the black dots here and copy them to every solder point. That's the way. Haven't really gotten this method to stuck real to my spine, so to speak, but yes, it's actually a quite good method, and because you know, if you have a layout that just looks like that, it looks like you're gonna put the component here and then solder it. It is possible, but it is very how do you say? It is unnecessarily hard to solder components on the wrong side. So now just take this and send it forward, bring it forward like this. Oh no, I did it wrong again. Why did I do it wrong? Yes, right. So we need the dots to be on the top, then the layer. So we have to select every component and wire, which is a bit of a drag, but what can you do? Ah, I forgot one solder point there. That's good to know. No, I didn't. It's underneath. Okay, I see. So, if you hold down Control, you can select a lot of things, one after the other. Just remember, don't press the board itself. So, then we ask these politely to go backwards. Yes. So, there you go. This one didn't want to do that. Alright, and then we can just slightly make this transparent like this, and then we can delete the wires that are sticking out like this. And finally, we take a board that is a blank board and put it on top of this board right here, because that is sort of how it looks from the other side. And now we also see everything. So this is the best I can do. And yes. Let's see. And we just gonna make a close up, and open up, close up, zoom. Oh, sorry. Sorry about that. I'm such a clumsy. Alright. Image, crop, file, save. And then we import this image, and yes, make it 150%, and we can actually see it if we choose to print this particular thing. So yes. So this is sort of square and frequency modulation, square slash freq. Yes. And yes, 08 through A. Okay, and then file save as B. Yes, beautiful. And then what we will do is just the buffer. Yeah, so we have to make this triangle. Yes. So this now we are making a new thing right here. Or I mean not new, but a variation. And then we will need some more space here. We could keep the square output, but it would be sort of not necessary. So instead we write triangle here, and that should be sort of like this maybe. And we add another pot that will be our amplification pot. And for simplicity, I will just take a new. I don't know if this is more simple or more hard, but because I did the doubling of this, I will take a new one here, which means it's a new piece of strip board. But it can be very small. It just actually needs to be very small, but it needs to have some holes here. Yes, we don't need more. We can copy it. We don't need it from the horse's mouth anymore. So what we need now is a pinout of a double operational amplifier. So we just look in here and we take it out, and it's looking great, I can tell you. Yay. So we need this in order to be able to use that little triangle in the schematic, because it's a ship. It doesn't look like this, it just looks black. So it's hard to use it actually if you don't know by heart how it works. So if we then zoom into this part right here. So what we did now was we disconnected here, this one. So we have no output from the output pin. Instead, we take output from here and take it to this operational amplifier here. So then we have to attach that operational amplifier right there. And it's called LM358 or possibly TL072. It's just you choose one or the other, whichever you have or whichever you feel like buying. The 72 could be considered having less noise, but who cares about noise when you're making noise circuits? Am I right, people? Am I right? So now we have to take, so you see, pin 2 on this chip to pin what? We don't know the number of the pin, but we look here to the same symbol, the plus sign right there. And that happens to be right here. So we just take this unbuffered triangle signal and we just route it straight into there. And just like voila, we have finished this part. Unfortunately, we have not yet connected any voltage to this little chip right here. So we could connect it to 12 volts plus and ground, but we're not going to use ground because I don't know why. I never did it, and I don't think it's the best way. So we will use a negative 12 here, so minus 12. Because we have it already up here, and we have not used it yet, but it's right here. So we just take a blue wire from, maybe then we should take this kind of wire, and we pull it to right here. Now things are getting messy here. Do you see how messy things are getting? And it's okay because it's not very complex circuit. And then here is all our positive voltage, and we need a positive voltage right now. So we take it from here and we attach it up here, because you see here it says VCC, and that means voltage plus plus. I don't know what it means, but I don't know what it stands for, but I know what it means. I know very well what it means. So then we have exactly what do we have here? I forgot. Yes, we have to build a buffer. To build a buffer, we connect the inverting side, which is the minus sign, right there. We take a wire from it. You see there, pin 2 right here. And we connect it to the output, which is right here, the pointy side of the triangle. So it's right there, meaning right here. So it's quite simple actually. We just take a line looking like that. And now we can take an output from here. from this net right here, and it is a buffered version of what goes in there, meaning that it is only going one direction and it is having very much current, as much as you want or as much as this can provide. So, but that was not all we wanted it to do, right? We wanted it also to give us yes, we are making things extra complex today, aren't we? We want more. And what more do we want? Well, we just follow this line right there and see what it is that we want the circuit to do. Yes, we want a filter here, a high pass filter. So, from here to here, and but this is also here. You see this point right here. I have to change the color now because it's not making any sense here. If we just take this color right here, so this point right here is everything in this is the same point or the same node or the same net in the circuit. So we have the other side of our thing, which is here. Oh my god, this is going very well. So anyway, here, from here to positive on the next one, which is over here, you see. Are you seeing this? Right there, pin number 5. So from here to here, we're gonna connect a capacitor. Could make it in a more beautiful way, but I make it just as ugly as this right now. So then we have exactly what? Yes, I will show you what we have. Now we have connected this part right here to this right here, and don't mind all of this scrap, it's just something I will erase. Yes, but we need this little 100 to ground here. So, from what was previously turquoise then to ground. So we just need a little ground. We don't have a ground on this one right here, but we have a free thing right here. So let's just connect ground to it. So we just find ground here. We have ground sort of everywhere here. And we also have ground going all the way to the panel over here. So we can take it from a lot of places. But I think the most simple way would be to take it from here and attach it here. Just like that. Unfortunately, it is now above the other one, so I just have to make some little adjustments here. So now when we click the net, sorry, so this is everything here is now a negative, a ground net. And from this point right here, you see, from this point right here to ground, like this, from here to ground, we are going to connect 100K. So from this point right here, which is the positive on the triangle, on this, so from here to here, 100K resistor. Let's just copy this because it will have the same way of looking like that. So now we actually have this thing working, everything. This is ready. Now we just have a little small thing left, and that is this part of this circuit. So if we maybe just zoom into it, we can see that the non-inverting input should go to a wiper on a potentiometer. So we can rotate this so we get the same rotation as the other one had. And check once again from the negative, the non or the inverting, which is pin 6 from here to here, here to here. So we just take a wire and just do that already. Am I right? Could actually copy this because I want to do that. No? Yes. Okay. Okay, so just a little adjustments are necessary. So I forgot what was the position of it. Pin 6, yes, alright, beautiful. And just take a new color. And just double check if it is actually right. So look at the image, or I mean the pinout. Okay, we are connecting to this pin right here, which is a inverting input on a triangular. So it's correct, and then we can paint it pink because pink is being incorrect. And you see the rightmost leg goes to ground. Right here to ground. So go to the panel and be happily surprised that you have access to ground so close by here. So just copy paste and attach it to where? Yes, the rightmost leg goes to ground. This is ground. So that is ready. Bum, 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 bum. And now finally, the point of the triangle, So here is the triangle. Remember, now we're using the triangle to the right side. So pin 7 right here. I said right here. So this one needs to be attached to 2 points. So both to the left leg of the potentiometer and to the output. So we need one wire from here. There's enough with one wire. Let's make it a beautiful color. Because beauty is so much important in this world, Without beauty, where would we be? Alright, shut fuck up, and yeah. So from here to here, now things are getting starting to look really ugly here, but we're not making art, we are making another thing. And now as we remove the output from the output 3 pin, we take it down to our new position right here. So there you go. We're actually done. I think done at least. So I'll bring it forwards and if you're not quick and dirty, you can clean up this messy drawing. So no cables are crossing each other and so on. I actually don't like long wires. I prefer to use net flags instead, so you can have, I'm not sure we can have that in this program, but sort of you put a little arrow here with a little code on it, so you could put like A, and then you put an A over here, and you don't have to have all these long leads going from here to here and there and crossing each other and making a mess, but that's another way of doing it. Alright, so this is the triangle version, and I will save, and I will export. No, wait a minute. So we need to maybe make we could, if we would want to do that, we could make another copy of this and invert it and all that. But I don't want to do that now. I'm so tired. So let's just export this PDF and boom. We're down to earth. Why don't you say 555? I think you should say 555 now. So this is frequency. We need to change this maybe to frequency. And this right here, which doesn't even exist, we will call this a amplitude, or sort of volume slash shape, like that. And then we save again, file, save, file, export, PDF, bam, there you go, we are done. Alright, hope you liked this video. It was only, oh, let's stop right